Algebra, Chapter 1, Lesson 7, and we're looking at solving equations, and we just talked about some different ways that we can solve an equation. If the replacement set is small, we can simply substitute each value from the replacement set into the equation and determine which one or more make it true. For those whose replacement set is really large, as in all real numbers, if the equations are easy, meaning there's like really small numbers or only one operation, then we can do that mentally or by trial and error. We want to begin now looking at how we can solve equations that are more complex and some of the math behind it. Before we do that and look at the specific properties, we want to talk a little bit about equivalent equations, because that's really what we're going to be doing in algebra, is creating equivalent equations. So we need to know what they are. Equations are considered equivalent if one can be obtained from the other. Okay, so we begin with one and then somehow we're able to create or obtain a new equation. And the way we do that is by correctly using mathematical properties. And then equivalent equations have the same solution set. So when we're talking about equivalent equations, we're talking about equations that are equal. Their expressions have equal value if you substitute in a particular number or the solution set. We can obtain one equation from the other if we correctly apply math properties. And if we've done everything correctly and we correctly apply the math property, the solution set for both equations or three equations or however many equivalent equations we come up with is going to be the same. So when we have the equation x plus 4 is equal to 10, that's equivalent to the equation x plus 6 equals 12 because they both have the same solution set. If I substitute 6 into this expression, I'll get a true statement. If I substitute 6 into this equation, I get a true statement. So they both have the same solution set, which means they're equivalent. And it also means that I should be able to get or obtain this equation from this one or this one from this one, vice versa, by using some math properties, okay, and by using these mathematical properties. So that's what equivalent equations are, and that's going to be the key to determining these solutions without having to use mental math or to use it by trial and error. Now, a good picture when we're looking at equations, we talked about when we began this lesson that the equal sign makes a statement about two different algebraic expressions. And what the equal sign says is, look, this expression over here and this expression over here have the same value. So you can kind of think about it as a scale. The equal sign being in the middle, and you take this mathematical expression on the left and you put it on this side of the scale, and you take this mathematical expression and you put it on this side of the scale, and you have an equal balance. They're equal in measure. So in order to solve this mathematically then, it's our job to then apply mathematical properties in such a way that this scale never gets out of balance. Okay, we have to keep the scale balanced because the original statement says, look, this x plus 4 and this 10 are of equal value. So if I'm going to change either one, I have to make sure that I do something that keeps the scale balanced every time I create a new expression, so that each new expression keeps the scale balanced. And the way we do that is by correctly applying different mathematical properties. Alright, so that's what equivalent equations are. The goal is to keep the equation equal as we go through and create new expressions, and we're going to use mathematical properties to do that. So in the next video, we'll look at some of the mathematical properties that we can use that will take an equation that's balanced, that's equal, and keep it balanced even though we change what it looks like or we create this equivalent equation.